my name is Alana Joy Morrison, and I am from the FTC team 7129, the Robo Raiders. Here I have a conversation that I had with FIRST Alumni Jamari Morrison about Wiki programming. This particular conversation is just audio, but I hope that it can be as helpful and informative as the rest of our videos. Hello everybody, I'm here with Jamari Morrison. If you'd like to introduce yourself.
Hey everybody, I'm Jamari Morrison. I did FTC for 4 years, and I did FLL for an additional 2 years, and now I'm going into my second year of college at Rose Hulman Institute of Technology as a computer science student.
Yes. So we have 7 questions, all related to FTC programming. So we'll go ahead and start with the first one. What language should you use?
So yeah, if you're trying to learn programming, if you're doing it specifically for FTC, then Java is the obvious choice, but Python is another widely accepted language. If you're not particularly interested in going into the computer science industry, then I would actually recommend using the blocks programming language that is specifically supported for FTC. It's a lot simpler than trying to learn Java, but it's not nearly as transferable into the real world.
So how exactly do you get started?
Yeah, to get started, since we use Android Studio, pretty much what you can do is Google how to set up Android Studio and follow any of the many tutorials, or you can actually go onto the Robo Raiders website where we have documentation on getting Android Studio installed, the FTC app installed, and set up. Then you need to learn the programming language of your choice, and again, this is just a very simple Google search. There are plenty of resources available online. There's so many resources available that, yeah, it's really easy to get started.
So, since there are so many of these resources, where exactly do you find them?
So yeah, as I mentioned earlier, you'd probably just want to do a Google search, but you can also take a look at the specific documentation of the framework that you're using. So for instance, if you take a look at the FTC app, then you could go into the FTC apps documentation to learn more about the functions that you're using in there.
So, on a lot of teams, they have problems with giving programming enough time, and mostly they're working on the robot and not actually making it move. So how can you give programming enough time and they can do everything they can do?
Yeah, that's the classic programmer joke, how you got the autonomous working at 2 a.m. the morning of the competition, right? So, I mean, really, you just have to recognize the importance of programming. So if a working autonomous or a working robot at all is important to you, then you need to give adequate time to programming to be able to get that done. And just remember that programming is not simply downloading code onto the phone and getting it to run. It's an entire process where you download it, you get it to run, and then you need to go through levels of testing, and then after that testing, and you have the code running functionally, you then need to do consistency testing, where you make sure that the code runs correctly every time.
So another problem that a lot of teams have is that they only have one programmer that actually does things or at all. So how can they get more people involved in actually doing things in programming?
Yeah, so I guess the big thing that you'd want to make sure is that you design your code from the start that it is modular. So you want to make sure that you are not looking at your code as one big block, but instead breaking it up, of course, into teleop and autonomous. But then say teleop, you want to break up into driver and operator. Those are 2 tasks right there. And then for autonomous, again, instead of one long running program, you want to look at it in parts. So you take, say, driving, that's one part, and then all of the different tasks that need to be done in autonomous, whether that's turning, whether that's moving an actuator, those are all parts that each person can work on. You do still want for one person to be putting all of these pieces of code together, however, and you want for all of your different programming members to be using the same nomenclature when they're programming.
So a challenge, at least for us, is, well, me personally, is how exactly to document your code.
Oh, documentation. Okay, so generally you just want to follow the general good standards of documentation, because the engineering notebook for programming is going to be the same as engineering and fabrication, except you'd want to include code snippets and screenshots of your paths that you're taking in autonomous instead of CAD and robot pictures. Inside of your code, you want to comment, because that is really going to be your best friend. Each individual line doesn't need a comment, but someone should be able to easily understand how everything inside of your code works from just your inline comments. And you should also have leading comments before functions. so that somebody who does not want to go into your function to try to figure out the code can still know what that function does.
How do you plan your program to have it work the way that you intended it to and the best way that it can?
Okay, yeah. So to find the best way that it can work, you would just want to use a decision matrix, just like engineering. So you take in a couple different factors. This would include, say, the position on the map, how difficult it is to get there, how many points that task is worth, how far away that task is from other tasks, and then, of course, your consistency and ability to do that. Then you would just use those, rated on each of those points, and then you'd pick the best autonomous options for autonomous, that would be. Then, as far as starting your code is concerned, you'd really want to start by making flowcharts, because, first of all, the judges absolutely love flowcharts, but they also allow for you to be able to see the flow of your code before you write anything and make any big mistakes inside of the code, and makes it easier for you to find logical errors inside of your code. Then you'd, of course, want to make experimental code that has all of the functionalities that you need, and then you would take that experimental code and you'd do cleanup. You'd make sure that it is following the nomenclature that your team has set up.
Thank you for your time and all of your wonderful answers.
All right, no problem.
Thank you for watching this video on programming tips with Jamari, an engineering student at Rose Hulman. This is our 5th video in our Game On series, and next week's video will be on documentation. Stay tuned. Bye.